Friends, this will be the third lecture of the chapter Thermodynamics of class 11. Okay, now here we will discuss in this video about the internal energy of the system and the zeroth law of thermodynamics and also the first law of thermodynamics and about the enthalpy of the system. So what is internal energy of the system? Internal energy of the system. Now this is the energy of the sum of the all kinds of energy can be held in a system. That means a system can have its rotational energy, vibrational, translational, and bond energy, kinetic energy, potential energy. So all kind of system energy is sum of the internal energy. Okay, so when we will sum up all the energy, then we will get the internal energy of the system. Okay, so total energy, it is nothing but the sum of all kind of energy of a system. It is called the internal energy and it is denoted by E or U. Okay, now internal energy we can write E equal E translational plus E rotational plus E vibrational plus all kinds of energy. Okay, E bond energy plus dot dot dot. So sum of the all kinds of energy is the internal energy. Okay, now this internal energy we cannot measure the absolute internal energy. This one we have to keep in mind, that we cannot measure the absolute value of the internal energy, but we can measure the change of the internal energy of a system. Okay, that means when a system goes from one state to another state, its internal energy will change. Now that change we can measure, but the absolute value of the internal energy we cannot measure of a system. Okay, so we can measure the delta E value, that means the change of the internal energy, if the internal energy of the system in its final state is EF and in the initial state is EI, then the difference we can calculate, that means delta E. Now some of the characteristics of the internal energy are there, that one we have to learn here. Now what are the characteristics? Now internal energy is the extensive property. Okay, first of all you have to learn internal energy is an extensive property. It is an extensive property. Next, it does not depend on the path of the system. That means how it changed from one state to another state, the path, it does not depend on the path of the system, that means change of the system. Okay, and for the cyclic process there is the change of internal energy is 0. Okay, for cyclic process the change of internal energy is 0. These two things are very important. Okay, these 2 points are very important, and we cannot measure the absolute value of internal energy, we can measure the change of internal energy. Okay, change of internal energy can be measured. Okay, so this is the about internal energy. Now we will discuss about the first law of thermodynamics. Before that we will discuss the zeroth law of thermodynamics and thermal equilibrium. Okay, concept of thermal equilibrium and zeroth law of thermodynamics. Now how this concept comes actually, when two body, one is hot and one is cold. So when a hot body comes in contact with the cold body, then there will be a transfer of heat. When a hot body comes in contact with a cold body, then there will be a transfer of heat from hot body to cold body, that is the heat. Now the internal energy of the hot body will decrease and the internal energy of the cold body will increase. and a time will come when there will be no transfer of the heat from hot body to cold body, and that time equilibrium will established, and that equilibrium will be called as thermal equilibrium. That equilibrium will be called as thermal equilibrium. Now from there we can know about the zeroth law of thermodynamics, and actually it is formulated after the first law and second law and third law of thermodynamics. Actually thermodynamics consists of 3 laws, but this is about the thermal equilibrium, and it tells what this zeroth law of thermodynamics tells. Actually zeroth law of thermodynamics, it is very important. Zeroth law of thermodynamics: when two bodies A and B are separately in thermal equilibrium with C, then if it happens A and B both are in separately thermal equilibrium with C, then they will be also in the thermal equilibrium. This is the statement of the zeroth law of thermodynamics. Okay, so we have learned about the zeroth law of thermodynamics, internal energy, and also about the thermal equilibrium. Now we will do the discussion of the first law of thermodynamics, which is the basis of the thermodynamics. Okay, so we have to learn that one properly. So let's see. Start the first law of thermodynamics. Now this law is formulated by the Robert Mayer and Helmholtz. So there is so many definitions or the statements are there of this law, but all of these are more or less similar, and it is the law of conservation of energy. Now what is the law of conservation of energy? We know that energy cannot be created and cannot be destroyed also, but it can transfer from one state to another state. Okay, so this one we have to keep in mind, that energy cannot be created, cannot be destroyed, but it can transfer from one energy state to another energy state. We can say this statement by another type, that the total energy of the universe is constant. This is another statement of first law of thermodynamics. Another is there that it is impossible to form a perpetual machine which will work totally by without absorbing any kind of heat energy. So there are so many definitions or statements are there of this first law of thermodynamics, but all of them are similar, that is the conservation of energy. Now how we can express the mathematically this first law of thermodynamics: if one system change its state from one state to another state, then its internal energy will differ. If the internal energy of the system in A state is EI, that means initially EI, and it goes in another state which is B, and here the internal energy is EF, then the change of the internal energy we know that EF minus EI, that is delta E. Now this change can be made by any method. By 2 ways we can done this change: by do the work on the system or on the system, or work done by the system, or we can give heat on the system, or heat can be evolved from the system. So by 2 ways we can do this change, that means change in the internal energy. Now if this system which is in A state, the internal energy of the system is in A state, and here the internal energy of this system is E. It is the internal energy of the system. Now Q amount of heat is given to the system. Now for that the internal energy of the system is increases. It becomes E plus Q. Q amount of heat is given to the system, so the internal energy of the system increases and becomes E plus Q. Now if work is also done on the system, then internal energy becomes E plus Q plus W. Now say the initial internal energy is E1 and internal energy becomes E2. So here the internal energy is E1. After giving heat and work, after doing work on the system, that is plus Q, and giving heat on the system, that means plus Q and plus W, then the internal energy becomes E2. Okay, so internal energy is the final here, which is E2, and which is sum of the E1 plus Q plus W. Work is done on the system, that wise it is plus W, and heat is given to the system, that means plus Q. Now we can write from here E2 minus E1 is equal to Q plus W. So it is del E equal Q plus W. It is the mathematical relation of first law of thermodynamics, as heat is given to the system, on the system, and work done on the system. Now if heat is absorbed by the system, that means it will be plus Q, heat absorbed by the system plus Q, but work is done by the system, then we can write del E equal Q minus W, because work done by the system is negative. Okay, so this is the first law of thermodynamics. Okay, so I think it is clear. So today's video is up to this. In next lecture we will discuss about the enthalpy of the system, and after that whatever is there we will discuss. Okay, so thank you everyone.